Alright, hello and welcome everybody to another physics lecture. Today we are going to be talking about velocity. Alright, so let's just recap real fast because we've seen the word velocity before. Okay, so if you remember, when we have a position versus time graph, alright, time goes on the x-axis, position goes on the y-axis, alright? When we find the slope of this line, we're finding the change in y over the change in x. So the change in position, or distance, or displacement, right, movement, okay, divided by the change in time, okay? Now, I use the word displacement here because our change in y can either be positive and go up and give us a positive slope, or it can be negative and go down and give us a negative slope. Right? The slope of this graph is the velocity. All right? This is what we learned last class. And we remember that the steeper that slope, the faster our velocity is going to be. So, what is velocity here? All right. We need to compare velocity to its cousin, which is called speed. All right? I'm sure you've heard of speed before. Speed is simply how fast something's moving. All right? And in this case, the way we calculate it is we do distance divided by time. Now you may remember that distance is scalar, okay? And speed is scalar, all right? Which means it can never be negative, okay? These distances, no matter which way you're going, forwards, backwards, left, right, you just add them all up, okay? Velocity is different. Velocity is displacement divided by time, meaning that it's a vector, which means it can be negative. So velocity cares. If you're going forwards, it's positive, and if you're going backwards, it's negative. And again, I've included a little picture here. If the car is moving forward, its speed is 25 meters per second. Its velocity is positive 25 meters per second. And if we're going backwards, our speed is still the same. It doesn't matter. It's still 25 meters per second. And our velocity is negative 25 meters per second. Okay? All right, very good. Both of them use meters per second. And just a real quick tip here, the way that I remember scalar and vector is I remember that speed is scalar, right? Speed is never negative. Think about your car. The speedometer on your car is never negative. And velocity is a vector, meaning it can be negative. Hope that helps. All right, so let's jump forward and look at these ideas real quick. So real fast, we're going to talk about average speed and average velocity. So if you have a graph, position versus time graph, this is just what we saw last class. If somebody asks you to find the average speed, okay, you want to take the total distance and divide it by the total time. How do we find the total distance? Well, look at every line and add up its distance. So from A to B, we don't move up or down, so our total distance there is 0. We're going to add that to B to C. We go from -5 to -2. That is a total of +3. 1, 2, 3, right? C to D, very good, we're not going anywhere, right? The line doesn't go up or down. And then from D to E, we're going from -2 to 8, all right? So this goes from -2 to 0, which is 2, and then 0 to 8, which is 10. So the total jump there, -2 to 8 is 10. And you can do this mathematically by going your final minus your initial. 8 minus -2 is 10. E to F, we got another big goose egg, right? We're not going up or down. Goose egg means 0. And then F to G, we're going from 8 down to 0, which is another 8. Oh! It's a lot of writing. Now, remember, Mr. Norris, you're going down here. Yes, but this is speed, so we don't care if we are moving up or down. We just add them. So what we have here is 3 plus 10 plus 8, which gives us 21. Okay? This is our total distance divided by our time. Which time? You just look right here. Boop, 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 boop. 44. Okay? 21. Our total distance divided by 44, our total time is, I had to write this down, 0.48 meters per second. So that is the total, or the average speed. If you ever see average speed, add up the distances and divide it by the total time. Easy. Right. Whereas average velocity is different. Average velocity is the total displacement divided by time. This is even easier. Remember, my displacement is how far I am from where I started. So if I start at -5, right? And then I go all the way to the end, at the very end of this time, I look here, and my displacement's at 0. So I went from -5 to 0, which means my displacement is equal to 5. And we're going to divide that by the total time, which is still 44 seconds. And this gives us an average velocity of 0.11 meters per second. Notice that this is less than the average speed because we had a negative, which is going to slow down your total average. Okay? And we don't see a ton of average speed and average velocity problems, but I want you guys to know this. Now, moving forward, what we're going to talk about today is our first word problems. So in order to understand how to solve word problems, you got to do 3 things. Okay? And we'll get to the steps, but to calculate a word problem, what you got to do is you have to circle the variable that you want. So you have to know what you're looking for. Okay? The next step is if you remember something called PEMDAS, we're going to use it or we're going to go backwards. If you don't remember what PEMDAS means, we have parentheses. Okay? E is exponents, M is multiplication, okay? D is division, A is addition, and S is subtraction. This is your order of operations. When you solve a problem, you go from left to right. But we are going to go from right to left to break them apart, okay? And we're not going to get too deep into this today, but keep this in the back of your mind for when things get a little more complicated. And then the last thing you're going to want to do is whenever you have an operation, do the opposite of that operation, okay? This may sound complicated, so I'm going to go through a few examples to show you that it's not. You probably already know how to do this. Okay. So let's go through a couple of these real fast. All right, number 1, x minus 2 equals r, find x. All right, okay, a little basic geometry. All right, so here is how we are going to do this. We're going to write down our equation, okay? X minus 2 equals r, all right? If I want to flip this around, okay, I would circle what I want, which is x, okay? And now I want to isolate x. I want x by itself, which means if I want x by itself, it's got to be alone on this side of the equation, right? So what I'm going to do is I'm going to find my operation, which is subtraction, and I'm going to do the opposite. What's the opposite of subtraction? Addition, right? So I'm going to add 2 to this side. Remember, this equal sign means both sides are the same, so I have to do the same to this side. So now, I bring everything down. -2, +2 is 0. So I bring down x equals r plus 2. X is isolated. We just found x. X equals r plus 2, whatever that is. All right? Let's do another. B plus C equals D. Find B. We don't even have numbers in this one. Does it matter that we don't have numbers? No. We just have variables. Let's move them around. So here we have B plus C equals D. We want to find B. So again, circle what you want. We want B by itself, which means I have to move C. Very good. This is addition. So we do the opposite of addition, which is subtraction. And whatever I do to this side of the equation, I got to do to this side of the equation. Subtract C. C minus C is 0. And this gives me B, only thing left here, equals D minus C. Okay? So if B plus C equals D, B equals D minus C, which is a mouthful. But as long as you follow these operations, circle what you want by itself, and then do the opposite of the operation. All right? Let's do another one. Okay. Y equals x divided by q. Find x. Okay. Y equals x divided by q. Okay, again, here I'll do this in red this time. Maybe this is a little better. We want x by itself. Okay, first fraction of the year. So what do we have to do here? Well, I need to move q because I want x by itself. Okay, so this is division, right? What's the opposite of division? Well, multiplication, of course. So we're going to multiply both sides by q. You always multiply by what's in the bottom of the fraction, okay? Multiply both sides by q. Why do we multiply by the bottom of the fraction? Because now q divided by q, anything divided by itself is 1. Check your calculator to find that's true. Q divided by q is 1, and then this gives me an answer, which is q times y equals x. X is by itself, q times y equals x. All right? You can always slow down the video, stop it, go back. Okay? Next, m times n equals p. We want m by itself, so we're going to circle it. I want m alone by itself on the side of the equation, which means I have to move n, right? This is multiplication. So I have to do the opposite of multiply, which is divide. And I want m by itself, so I'm going to move n. I could have picked some letters that sound a little different. My apologies. Remember, this is an equal sign, so whatever we do on this side, I have to do the same thing on this side. They have to be equal. So I divide this side by n. Again, anything divided by itself is 1. M times 1 equals m. All right? For example, 5 times 1 is 5. So m is by itself, and I bring this down, p divided by n equals m. Now maybe you're starting to see that we're just kind of moving, right? If something is in what I call the top of the fraction on this side, you move it to the bottom of the fraction on this side. Like we saw last example, if something's in the top of the fraction, you move it to the bottom. And there's always a few ways to see this. I like thinking about it in a purely mathematical sense. All right, the last one, and this is the hardest, okay? We have r equals t divided by s. We want to get s by itself. Okay, the reason this is the hardest is because there's 2 steps. S is in the bottom of the fraction. We can't have s be in the bottom of the fraction if we want it by itself. So that means we got to move s first. If your variable is in the bottom of the fraction, your first move is to move it. So we have to do the opposite of division, which is multiplication. And remember, we always multiply by the bottom of the fraction. So what this gives me now is s divided by s is 1. Okay? T times 1 is t. And on this side, I have s times r equals t. Right? T is by itself, and now the s is on this side. Now remember, I still want to get s by itself, so I have to move the r. Well, this is multiplication. So now I'm going to do the opposite of multiply, which is division. But this time we're not dividing by s, we want s by itself. So we have to move the r. R divided by r is 1. And I bring everything down. This gives me s equals t divided by r. Okay. These are the different types of moves that you will see throughout the year. And I can be 100% honest where if you understand how to solve these 5 types of equations, this is like 85 or 90% of the math that we do in this class. So we're going to be practicing these a lot. Okay, let's look at some real examples of how to solve a word problem. Every word problem that we solve, we are going to use what is called the guess method. Hopefully you've heard of it before. If you haven't, it's pretty straightforward. What we do is we find our givens, which is what the problem gives us, what they tell us. We write down our unknowns, which is what we're looking for. We then pick our equation. Lucky for us, today we only have one, which is great. Throughout the year, you're going to have more than one equation, and you will have an equation sheet to choose from. All right? Next, we sub in our givens and unknowns into the equation, and the last thing we do is solve. We are going to solve every problem for the rest of this year using this method, and I promise you, it's not as hard as it seems. Okay? So, hold on 1 second. Let me give myself a little space over here. Here, do I have enough space right now? This all this? Okay, so how are we going to solve this problem? In fact, you know what? I love this snail, but it's a little in my way, so I'm going to put it over here. And I'm going to do the same thing. Give me 1 second, guys. You guys are awesome, super patient. I know, I should have done this before I started. You're right. If I was better at editing, I would take this out, but as you will see, I'm not the best video editor. Okay. What was that? A minute, maybe? Okay, 10 seconds. Let's find this snail's velocity. Okay, the first thing we're going to do is write down our givens. How do we find this? We read the problem and we write down what we know. Okay? A snail moves 3 meters in 60 seconds. All right, this is what I know. Find your numbers. A snail moves 3 meters. So what we're going to have to remember is our units. These are super, super important, all right? Meters, if you remember, always measures distance, or technically displacement, but honestly for the rest of the year, I will probably just use the word distance because everything is just moving forward from here on. Distance is equal to 3 meters. Boom, I write it down. We're gonna make a chart. Next up, I have 600, I think I said 60, 600 seconds. Seconds measures time. Okay? These are my givens. Step 1, done. That's my givens. Next, what's my unknown? This is easy. What am I looking for? Well, I'm looking for his velocity. So I put V equals question mark. Every question you do for the rest of the year, make this chart. This chart will save you, I promise. Okay? Now we have this. We're going to write down our equation. We only have one equation for today. Velocity equals distance over time. Again, technically displacement. We're going to say distance. All right. Next, we need to substitute our variables in. So look, I'm going to sub in. V is equal to V. So I don't know what V is. D is equal to 3. And time is equal to 600. So now look at this. Now I've substituted in, okay, my variables. And the last thing I have to do is just solve. Well, let's look. I want to know velocity, so I circle this, and well, look at that. Velocity is already by itself. It's already isolated. So all I have to do is the math. And if you take your calculator, boop, 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 3 divided by 600 gives me 0.005. Okay, I wrote these down. Yep. And now we just need our unit. So remember, velocity equals distance over time. So my unit is meters per second. Distance is meters, time is seconds, velocity is meters per second. Meters divided by seconds. And there is how you solve a problem. Okay? Good? Let's do another. Now again, there will be times, like in this one, where you just want to jump to your calculator. Don't do it. Okay? Resist the urge. No matter how simple you think the problem is, if you write down, just take 10 seconds, make a chart, write down the equation, you'll get the right answer every time. All right, let's do it again. A car drives at 40 meters per second for 20 seconds. Let's write down what we know. 40 meters per second. Here's why units are important. As soon as I see meters per second, I know, boom, that's a velocity. Okay, because I know my units. Okay, 40 meters per second is my velocity for 20 seconds. Seconds, as I remember, always measures time. And it says, how far does it travel? Ooh, very good. So now it's not explicitly asking, so I gotta figure it out. If I'm looking for how far something goes, I'm looking for distance, right? Great. Givens, check. Unknowns, check. Write down our equation. Velocity equals distance divided by time. Boom. Plug my numbers in. Velocity is 40. Distance is, I don't know, so we keep the D. Time is 20 seconds. All right? So now we circle the variable that we want. I want distance, okay? Distance is not by itself, so I have to do some math. We gotta move some things around. I gotta move this 20. So we look at it. What operation do we see? We see division. So what do? Well, we do the opposite of division. And the opposite of division is, you guessed it, multiplication. And you always multiply by the number on the bottom. So I'm going to multiply this side by 20, which means I got to multiply this side by 20. Okay? This gives me 20 divided by 20 is 1. Okay? So here I'm going to bring down my D equals 20 times 40, which gives me 800. And this is a distance, so I always need my unit, which is meters. This car traveled 800 meters. Take a second, okay? Whenever you see division, you always do the opposite and multiply. You always multiply by the number in the bottom of the fraction. Whatever you do to this side, you do to this side. And all I did here was just switch the sides they were on. They're equal, right? I can switch them. All right, very good. All right, let's do one more. All right, how long will it take a man running 4 meters per second to travel 100 meters? All right, same thing. Write down what we know. He's traveling 4 meters per second. Okay, if you want to pause the video right now and solve this, pause. All right, did you get a number? Let's see if you're right. All right, he's traveling 4 meters per second. Meters per second is our velocity. Meters per second is always a velocity. He travels 100 meters. Meters always measures, you guessed it, distance. And it says, how long will it take? How long something takes, exactly, is time. T equals question mark. I got my givens, my unknown with my question mark. Okay, that's G, that's U. Now I'm going to write down my equation. My equation is velocity equals distance divided by time. Okay, I'm going to plug my numbers in. My velocity is 4. That equals my distance, which is 100, divided by T. Okay, now if you remember, this is the trickiest whenever you're trying to find the bottom of the fraction, because there's 2 steps. First thing we do, circle the variable. Now, we see this. The variable is in the bottom of the fraction. We cannot have that. So we have to do the opposite of what we see. We see division. We do the opposite, which is multiplication. So I'm going to multiply this side by T, because it's in the bottom of the fraction. And I'm going to multiply this side by T. Okay? T divided by T is 1. Okay? So I bring this down. This gives me T times 4 equals 100. All right, good. We check to see our variable. Time is what we want by itself. It is not by itself, so we have to move the 4. What do we see? We see multiplication. What do? We do the opposite of multiplication. We divide. and we divide by 4, because that's what we want to move. And whatever I do to this side of the equation, I got to do to this side of the equation, okay? 4 divided by 4 is 1. T times 1 is t, okay? So I bring this down. This gives me t on this side is equal to 100 divided by 4, which is 25. And my unit here for time is always seconds. All right? Take a second. Okay? I promise. Okay? We're starting off simple. All right? Even if you think you can do this math in your head, I think that's great. But what I'm telling you is to start off making good habits. Okay? Waxing on and waxing off. If you go through the motions, make the chart, write down your givens and your unknowns. Write down the equation, plug your numbers in, and do your math. You'll always get the right answer. Okay? All right, guys. That's it for today. If you have any questions, you can email me at rnorris@dallasisd.org. Have a great day. All right?